Hello and welcome to the full build of the Ampelos Dagger, where I will walk you through the process that I did on making this incredible dagger inspired by the icon of the true vine. We begin the project by cutting even sections of steel. I'm cutting 6-inch pieces of 1084 and 15N20 high carbon steel, and these are going to be stacked and welded together. The 15N20 will be the bright pieces and the 1084 will be the dark. So now I'm welding the billet together after it's all stacked. Now there's going to be different varying layers of thickness for each color, and that'll show up in the final pattern. But to start, it all just looks like the same color of steel. All right, it's time to fire up the forge. My forge is a ribbon burner, which means that it's forced air, and it has a burner going across the whole section of the forge. It takes about 30 minutes to get up to forge welding temperature. So now we can see that the billet's actually already been forge welded together, which means that the steel has gotten up to a temperature where it becomes plastic and it can actually stick to itself. So here you see me drawing it out to get the length that I need to cut it and make smaller bars that I am later going to twist. After I've gotten the bar to the dimensions that I want, I put it in my straightening dies, my flattening dies, to make sure that it's all as flat as possible before cutting it up. This is one of my favorite parts of the process, which is the design phase. Usually I'll do my full template before I do any forging, but for this project I decided to do a little bit of the forging of the bar before I did this. What you see here are golden ratio calipers, and I use these quite a bit when I design. I have a few different variations of them, but I use them to make sure that I have golden proportions on a lot of elements of the design. So I'm using them right now on the design of the pommel to make sure that my spirals are proportionate to each other between the large spiral and the small spiral. You can also see that I'm only designing half of the dagger here. The reason that I'm designing half of the dagger is that I've folded my template in half, and once I have this fully done, then I can fold my paper in half and put it on a light table and get an exact copy on the other side so that it's perfectly symmetrical with itself. Usually when I design, all of my ideas are done first small in a journal that I have. That way, it's not going to take quite as much time as doing a full one-to-one, and I can have a bunch of ideas in a journal that I can sort through and look at, and when I have one that I really like that I want to actually do into a full build, then I'll take that and turn that into the 1-to-1 ratio template for the actual project. The reason it's important to have a 1-to-1 ratio is so that you can use the template to measure all of the pieces that you're doing. You can use it for reference points, and it's just really helpful. Once I started doing this, it really upped my game as far as actually executing what I wanted to execute. Once again, you see my large golden ratio calipers for getting some proportions on the blade. Another thing that I always consider when designing is how each line plays in relationship to the lines around it and then to the piece as a whole. You don't want to just be drawing without a purpose. Every line that you draw should have a direction and a purpose to it, and if it doesn't, then it's just going to end up chaotic and not as beautiful as it should be. So beauty comes from intention. It comes from having a purpose and direction to each line and how it plays into the rest of the piece. All of that being said, however, my final piece always ends up a little bit different than even the 1-to-1 template that I make, which is always a little bit different than what I drew in my journal. And the reason for that is because once you begin to see something three-dimensionally, and as the build goes into the actual piece, you might notice things that either you like differently, maybe it's something that you want to add or something that you want to take away. And sometimes when that happens, I will actually go back to the template, and I have some Scotch whiteout tape that I will tape over the part that I want to change, and I might redraw it. And other times, I just kind of go with it and just change it on the piece. Maybe it's something that I take away or add. So you'll actually notice when I finish drawing this piece that originally I had designed a fuller into the blade, and as I made the blade, I decided that I didn't want to do a fuller. I just wanted to keep it straight. Part of that was because of the pattern of the Damascus, and another part of that was just because I felt like there was a lot going on, and I thought that a fuller might actually take away from where I wanted the focus to be, which is actually what I'm drawing right now on the ricasso part of the dagger. I really wanted the focus to be here, and then on the shield, which is on the other side. So just keep in mind that just because you draw something down doesn't mean that it has to be permanent. Things can always change, but you also have to have a vision and a direction to where you want to go initially, and then things can adapt and change. The plan can always adapt and change, but you've got to have a plan. All right, now we're back to actually making the steel for the blade. We have the billet that I forged out, and I'm cutting it into 4 even bars that are each going to be twisted. You can see me twisting the bars here. 2 bars are going to be twisted clockwise, and the other 2 bars are going to be twisted counterclockwise. And then when you line each of those up, then you will have alternating twists going in different directions. After all 4 bars are twisted, they need to be re-squared so that you are able to stack them together. It's time to clean up each of the squared, twisted bars from the scale that's on them, and we need to make the sides that are going to be welded together flat. If that scale stays on the bars, then the bars won't be able to be forge welded. This is an idea of the alternating twists held together with some wire, and one end is welded, so that when I get it up to forge welding temperature with flux, then they can stick together. Initially, to set the weld, I use my hammer, and I'm just looking for the bars to stick. You can really tell it actually by the feel of the hammer. Once it begins to feel like a solid piece, then you know that the bars have stuck together. You'll also be able to see a color change in the bars. So the pieces that have been forge welded will all be the same color, and then the pieces that aren't stuck together yet, you'll actually see some variation in the color in the bars. Now, I start at the tip and then slowly work my way down the bar to make sure that the whole bar is stuck together. Now that the whole bar is forge welded together, I can begin to draw it out in my press. I like to take it slow. You'll see that I kind of had too large of dies to begin with, but I wanted to make sure that I didn't squish it too much, and make sure that I got the right proportions that I wanted. I also forgot to mention the white stuff that I am putting on the bar is flux. It's borax. And what that flux does is it prevents scale from building up and oxidizing in between the bars. Here you can see I cut the bar at like a V shape. This is to do a fish mouth weld. So that's cut, and then those 2 tips are forge welded down together to create the tip of the blade. And you'll see me forging in that tip right here. The cool thing about a fish mouth is it will actually make the pattern wrap around, so that when you look at it, there will be a core that kind of cuts off a little bit, and then the outside bars will be touching and the pattern will be continuous around the whole bar. Okay, all of the welds are finally complete. Now it's time to actually shaping the blade and drawing it out to the dimensions that I want. Once the blade is shaped, I'm going to cut off the excess, and I'm going to save this excess for some of the fittings later on. But the next thing that I'm going to do is begin to draw out the tang, which you'll see right here. So I'm going to squish it in the press to make sure that it's even on both sides, and then draw that out a little bit. And what you're going to see right here is I'm actually cutting out a chunk of mild steel. And what I'm going to do is forge weld this mild steel bar onto the little section of tang that I cut out. This does a couple things. It's actually going to create a stronger, in the end, it's going to be a stronger tang because the tang is going to be softer, so it can flex more. It's not going to be likely to break. The other thing that you're doing is you're going to be saving some of that Damascus that you worked really hard to make. Now, you can see here, I've actually probably used a little bit too much of the mild steel for the tang. I just really wanted to make sure that I had too much steel rather than too little steel. It's never fun to try and make a blade and then you find out that you don't have enough steel to actually make that blade. You can see on the chunk of mild steel that I rounded it off on the end. That's so that you don't create any sharp points where you want it to forge weld, and that you'll get a nice clean forge weld between the Damascus and the mild steel. Once the tang is forge welded on and drawn out to the length that I want, it's time to do the final straightening on the blade. I do a few different things. I'll put it in my straightening jig, and here I'll put it in my vise and slowly bend it back and forth to make sure that it's completely straight. I'll also do some taps with my hammer, very light taps at a low temperature, just to get everything perfectly in line. You don't want to, in the end, be starting to grind on the blade and then realize that there's a warp or something or a bend that's so bad that you're going to have to go back into the forge in order to straighten it. Once all of the forging is complete, then I will take the blade through a normalization cycle, which is one round at 1600 degrees, one round at 1500 degrees, and one round at 1400 degrees for 5 minutes each. And that will just make sure all the steel is uniform and the grain structure is good. And once that's done, then it's time to begin to clean up the blade. So I start by grinding off the big scale, and now I'm taking it over to my surface grinding attachment and making sure that the entire blade is going to be perfectly flat so that I can go ahead and work from there. It's important to have a flat blade so that everything is perfectly in line and symmetrical with the center lines. You can see me drawing out that center line right here. The blade is forged to shape probably 70 to 80%. And then I'm going to take the paper template that I made off of my 1-to-1 ratio drawing that you can see at the top of the video. And once I have that taper template on, I'm going to stick it on with magnets, make sure that it is centered on my center line of the billet. And then I'm going to trace that onto the blade that I forged out and grind it to shape from here. Also, depending on the pattern that you're doing, you might want to do a pre-etch to reveal that pattern. I did that here because this is a 4-bar twist, and I wanted the center of the bars, that midline, to be right on the ridge of where the dagger grinds were going to be. So that way I could actually trace over the center line of the pattern in the Damascus and then line up the center line of the dagger with that pattern. Once that's all done and traced on, then I go over to the grinder and grind that all to shape. Here you can see me shaping the tang. Not going super perfect right now. I'll do that later when I do all of the fit ups, but I just want to make sure that everything is pretty close to where I want it. Once the profile is ground, then it's time to start doing the layout for some of the more ornamental stuff. So here you can see me doing the ricasso layout. I'm getting all these templates, by the way, from that 1-to-1 ratio. I will put that over my light table and then trace over that with other pieces of paper so that I can get it as exact as possible to what I was originally wanting. Once I have my ricasso laid out, it's time to start actually grinding the bevels on the dagger. To begin with, I just grind down to the center line of the thickness of the dagger, and then once I get that established, I'm going to start slowly working back to where that center line is on the width. Once I have that ground, I go into the flat platen vertically to make sure that everything is as flat as it can be. You'll notice too, I'm staying away from that entire ricasso area. That's a big reason why I wanted to do that layout beforehand. And you'll see in just a minute that I'm going to finish that area with files because it's a very precise layout for the ricasso and it actually goes up onto the blade. It's a little bit different than a lot of other designs. It's definitely different than anything that I've ever done before, which here you can see I'm going in with files and I'm really just trying to match the same grind on the bevels that I did and getting it all flush and even together. Once I get the bevels filed in around the ricasso area, then I'm going to go in with EDM stones to really clean up that entire spot. The nice thing with EDM stones for this is that it can clean up the ridge of that ricasso as well as the blade. And then after the EDM stones, then I'll go in with sandpaper and get it nice and fine to where I want it. Time for hand sanding on the entire blade. Start with a 320 grit and then go up to 600 and then 1,000. And I want to go in alternating directions each grit to make sure that I get out all of the scratches from the grit before. I'm also using pretty thin and a firm backer to make sure that it's as flat as possible. Once all that's done, I begin to design the scroll layout for the gold overlay on the ricasso. Sometimes I will actually use a transferring method if I'm messing around with some different ideas. And other times, like you see right here, I will actually draw directly on the piece. It just kind of depends on the piece that I'm doing, how I want it to flow, and how it'll work out. The nice thing about drawing directly on the piece too is that you can erase it with a Sharpie. Once I have that layout established, then it's time to cut the grooves. So here you see me cutting the channels around the border. The border is going to be gold inlay, and then the overlay is going to be the scroll portion. So with the inlay channels, they need to be a little bit deeper, well, actually quite a bit deeper than the overlay channels, because you want to make sure that they're deep enough that when you sand them flat, there isn't going to be any gold that is going to come out. The blade is just about ready to heat treat. What I'm doing here is just getting out some of the minor warps pre-heat treat. I found that when you do that before heat treatment and you have a straight blade, the odds that it warps after heat treatment are a lot lower. A lot of times it's going to warp inevitably, especially when you have a thin blade like this that's this long, but I like to do it beforehand. I don't know if it actually does anything, but I feel like it ends up being straighter afterwards. So after heat treat, now I'm testing to make sure that the blade is hard. You can see me, just for the sake of this video, filing mild steel so that you can hear the difference, and then filing the hardened steel on the blade. A lot of times there's might be a little bit of decarb, which is like a thin carbon layer that hasn't hardened. And once you file through that, then you'll get to the hardened steel. But the hardened steel, you'll notice that when you file it, the file will skate across the top, versus if you file mild steel or something like I am on the Tang, then it'll really bite and dig into the metal. Once the blade has been successfully hardened and tempered, then it's time to spring temper the ricasso area, especially right up where the Tang meets the ricasso or meets the blade. That's a high stress point where getting at that spring temper will really toughen it up so that if it gets hit against something, it's really going to be unlikely to break. One of the cool things that I like about this video is you can actually see the high carbon steel changing colors, whereas the mild steel is going to stay that gray color because of the different carbon compositions in there. Mild steel doesn't have any carbon, or it doesn't have enough carbon in it to be hardenable, whereas the high carbon steel is hardenable. After all of that is done, it's time to start actually putting the edge on the blade. So you can see that I taped the ridge line of the Dagger to keep it from being ground away on accident. And I'm putting a convex edge onto the Dagger. This increases strength. It's going to put a little bit more mass behind the edge. And I found that that almond shape on the edge is really the best shape for a lot of different things. It provides a stronger blade, and you're still able to get a really thin, sharp edge, so it's still good at slicing. Now we actually get to test the blade. I test pretty much every blade that I make to make sure that the heat treatment held up, that it's strong. Now, especially a blade like this, it's probably never actually going to be used, let alone used like this to chop wood. But I want to make sure that the edge is going to hold up. So usually what I do is do a 2x4 chop, and I kind of vary it depending on the size of the blade, the length of it, the thickness, all of that stuff. It's really like how much stress are you going to be putting on that edge to make sure that it holds up. And so this one I whacked through 2x4 2 times, and then you want to make sure that it's still shaving sharp after you do that test. That's how you know that you have both a good heat treatment as well as good edge geometry. I also try, for the sake of testing, to really make sure that it's held up, especially on a blade this long, to actually just focus on one area when you're chopping. Because you could vary it up, chop at a whole different parts of the blade, and it's going to do less damage to the chopping overall. So if you focus on just one area, then you really make sure that that area is getting the brunt of the chopping, and that part of the edge is going to be having the most stress put under it to make sure that it can hold up. So anytime that there's testing like this, you actually want to make sure that you're really just focusing on one area to see that it holds up. Okay, the moment of truth. Will it still shave? Now, it was pretty cold out when I was making this, so I was wearing my jacket. And here I'm testing that area of the blade that I was focusing the chopping on, and it is still shaving sharp. So I will count that as a successful blade. Don't need to go back and reheat treat it. If I did need to reheat treat it, then I would probably need to grind the edge back a little bit. Not a lot, but just to get that thickness to where it's not going to cause any problems with the heat treating. And then I would have to retemper it and re-put an edge on it and go through the testing process again. So because of how the ricasso is, when I was putting the edge on there, I wasn't able to put it on the area near the ricasso. So now I'm going in with diamond files and putting that edge on the ricasso area, and then I hand sanded that out and cleaned it up too. Once that's done, I go over to my milling machine and I am just putting a tiny little shoulder where the tang meets the ricasso area, anywhere from like 5 to 10 thousandths down. I don't want it to be too much or else it's going to really thin out the tang. But I stage it a little bit. So I do one pass at like 5 thousandths and I'll go down another 5 thousandths, do another pass. I might do 2 or 3 of those. And then after I do that, then I will just taper the rest of the ricasso. It's important to taper the ricasso in both directions. Going widthways, that's called a distal taper. You want the same thing in the blade. And what that does is it creates kind of like a leaf spring effect, so that when the blade is put under stress to the side, that stress is going to be dispersed across the whole blade rather than just focused in one area, which would likely cause a snap. Now that the blade is finished, it's time to begin working on the hilt. I start by milling out the slot for the tang on the top of the guard. This is going to be the shield portion of the guard. And it's important on this one especially to get the tang slot very precise. You really want a tight fit up with all of your fittings to make sure that everything is going to be secure and not move around at all. Now that the slot is milled, I need to bend the shield over. So I'm heating it up with oxyacetylene to get it to a red hot, and that'll make the metal easier to move. And I'm just slowly tapping it. I don't want to put too much stress on that steel. Slowly tapping it as I'm warming it to make sure that I get the bend exactly where I want and exactly how I want it. Now that I have the tang slot milled and the shield bent over, it's time to actually start profiling it. So if you remember that scrap piece of Damascus that I had from the blade, this is that piece. I wanted this to match the blade. So I'm trying to get the center line of that shield to match up perfectly with the center line of the 4 bars. Once I have that all shaped roughly, then I'm going to start working on the next part of the guard. The first thing I do is square up the shoulders of the quillins on the guard. This is going to make sure that I get everything else lined up in square and everything's going to be parallel with each other, so that when I cut and drill and all of that stuff, it's gonna fit up nicely. And I didn't show this part, but it was just going back to the milling machine, doing another slot on the guard portion. And here I'm doing the main fit up process. So you'll see me fitting up a lot. I want to make sure, like I said, that everything is nice and precise. Once I have my fit up good, now I'm going to start squaring and flattening the guard so that it'll fit with the rest of the fittings and not have any gaps. The first thing I'm doing is just leveling off the top of it and making it all flat. And then I'm going to hand sand it a little bit, just because from the milling machine you get some, I mean, it's really precise, but you'll get a little bit of inconsistencies just with how the bit goes across the surface. And I want to make sure that everything is as flat as possible. Now that I have the one side flattened, I can go over to my height gauge and put it on my 1, 2, 3 block to mark out the depth that I want the guard to be, or the thickness of it rather. And that is going to make sure, having that one side flat is really just going to make sure that those lines are both perfectly straight. And once I have that line laid out, then I go over to my grinder and I'm going to start grinding down to that depth. This is just the fastest way to do it rather than milling all the way down. But as you'll see in a second, I'm going to clean it up with the milling machine once I get it down to the line that I want, to make sure everything's perfectly flat and straight with the other side. So here I'm just going through, once again, taking a little bit off at a time, making sure that the other side is going to be perfectly flat and matching the side that I originally flattened. Now that the guard is all fit up nicely and properly, the next thing I'm going to do is work on the fittings. So here I am surface grinding the material for the fittings. This is just some other Damascus that I did. It's just regular stacked. There isn't really a pattern in it. And once I have it leveled off on the surface grinder, then I go over to the bandsaw and cut from that material the dimensions I need for both of the spacers. Once each of the spacers are squared up, then I'm going to go over to my height gauge, find the center lines for everything so that I can drill and mill out the tang slot for both of these. Right here, you see me using my center finder on the milling machine to make sure that everything is straight with the line that I laid out. I do this every time I'm going to mill something new, just to make sure that everything's true and my line isn't going to be off at all. Once the spacers are all done, then it's time to start working on the handle. So I've already laid out where I need to drill for the tang, and I'm just going through. This is actually some elk antler that I had laying around. I originally used this material because I thought it looked like a grapevine and then it would be really cool. But as I found out later, when you see it, it doesn't quite look like a grapevine once it's shaped, but it still turned out really nice and I really like how it finished. I'm drilling 3 holes here, one in the center and then one on each side, making sure that I'm hitting the lines that I need for the dimensions. I don't go completely all the way, but I want it to be really close. And then I'm going to finish the rest of it with hand filing. So now you can see me, I have a square file, and I'm just going in, connecting all of the holes that I made, and then squaring up the inside of that to make sure that I have a tight fit on the tang. There's a lot of fit ups that go on in this process, and now I am checking all of the pieces that I've made so far, looking for light that could be shining through it all to make sure that every piece that I stack is going to be as tight as possible before I move on to the next piece. Here, I've already done that process with the center spacer, and now I'm going onto the bottom half of the handle with the elk antler. So just doing a video showing you how I do the layout for these lines. I'm getting the width of the tang to make sure that where that spacer is going to be is tight, and then I'm going to transfer that with my calipers onto the elk antler. It was a little hard to find center on the elk antler because it's not perfectly round. I do have a center finding square, but really only works on stuff that's like square or round. And because this is a weird oval shape, it was kind of hard to figure out. So I had to do a lot of work in math to figure out where that center line actually is, as far as where I wanted it on the handle, and making sure that so that when I shaped it, it wasn't going to be too far off or wonky from the top part, and that it was all going to fit up nicely with the rest of the fittings. It's important whenever you're drilling or milling something that the piece you are working on is going to be level and plumb with your drilling milling machine. So I use a double level that you saw right there, and I marked out on my table where the line should be because my table isn't exactly level with the floor. And so then I can transfer that onto the piece to make sure that it is going to be squared up once I begin to drill those holes. Once I know that the piece is level and plumb, then I can begin moving my table to find the center on the drill bit where I want to drill those holes. So that's what you're seeing here, just slowly moving the table and getting it lined up and then locking it in place. And now it's time to start drilling. Time for another fit up to see how everything's coming together. Start with the top, make sure that it's all square, putting all these pieces on. Now this tool that you're going to see me use in just a second, after I put on this front spacer, is called a monkey tool. Don't ask me exactly why it's called that. There's a bunch of different variations. The one I use is just a smashed metal pipe, but the idea of it is that it goes over the tang and then you hammer it down so that you're getting even hits on both sides of the fittings. And that's just going to make sure that everything is nice and snug and tight. The final piece is the pommel. So I need to mark out where the tang is going to go into the pommel. And this one's a little bit trickier because I'm not going all the way through. So I also have to mark out the depth that I want on the tang to make sure that I don't go too far. If I go too far, now I'm going to process Once all of the fittings are on there and I know that there's no gaps, it's time to start drilling holes for the lineup pins. What the lineup pins do is make sure that every time I am putting the handle together, they're all going to go in the exact same place, so that anytime I'm doing my fittings and things need to be really precise, it's not going to shift at all the next time that I put it back together. Right now, you can see me doing that process of marking out where the lineup pins are going to go. So I'm just going a little bit over from the tang slot, marking one on each side. Some people put their lineup pins in different places, and it all depends on the design of the handle and where they're going to go. So once I have that marked out, then I'm going to go in with my center punch, punch a couple little dimples, and that just keeps the drill bit from walking while I'm drilling. Once all the lineup pins are in, now it's actually time to start shaping. So I'm starting to round out some of that elk antler. Like I said earlier, it doesn't quite look like a vine anymore, but it still has a really cool effect with some of the smooth sides, and I tried to keep some of that texture of the antler in there as well. As I'm shaping all of the pieces, I'm going to keep doing some fit ups between each of them to make sure that all of the sides are even. Especially, I'm going to chamfer the sides of the elk antler down to where the spacers are. So I'm checking to see that it's even all the way around from that front spacer. And if I need to grind anywhere else, either on the front spacer or on the handle, then I can do that at this stage and not have to try and fix it later. I always do the final shaping by hand just so that I can make sure that it's extra precise. So now I'm going to go over the elk antler down to the lines that I want with some files, pretty rough files. And then once I get that down, then I'm just going to go through different grits of sandpaper to get all of those scratches out and get it really precise. Now I'm going to do the layout on the center spacer. The center spacer on this one was a little bit challenging because the handle was ovaled in the middle to give it a little more width where the swell of your hand is. But then the actual like little ball portion, I wanted to be perfectly round. So the first thing that I needed to do was get it equal distant from the elk antler onto where the spacer is going to be. And then when I actually start shaping the center ball, then that's actually going to have to be slightly different dimensions than the outside of the spacer because I wanted that to be round rather than oval. On the back spacer, I wanted to show you my layout process. So the first thing that I'm doing is finding the center of that spacer. Since it's squared, it's really easy to do at this point. And then once I have those lines, the cross section, then I can take my circle template and line it up to get a perfect circle where that tang is going to be. And then once I have that shaped, then I can transfer that onto the elk antler in order to get that to match up. Now that the back spacer is shaped, I can put that layout onto the elk antler and begin to shape that down. So I begin just by getting down to that line so that I can get that nice and clean, and it gives me a better reference to make sure that I don't go past anything. It's also better at this point because Sharpie or any type of layout can rub off over time, so you want to make sure that you don't have to keep redrawing it on there. All of the fittings are rough shaped now. And so now it's time to start working on the guard and getting it to shape. So the first thing that I need to do is find that center line so that I can make sure that everything is going to be equidistant and parallel with each other, especially the sides of those quillins. That's probably the most challenging part of any symmetrical piece, is getting those quillins to be lined up well. You can see that I also transferred my front spacer layout onto the guard. So now I'm taking my dividers and I'm getting it the distance that I want. And then I'm on that center line, I'm going from the mark that I made on the front spacer out so that I know each side of the guard is going to be equidistant from this front spacer. And then I'm going in, adjusting it, and going into these little corners and making more marks. And all of this is going to be for when I do the shape of the guard layout or the profile of it, that they're all going to be the same on each side. So you're going to see me make a little template, and this is where I'm going to line that template up to make sure that it's the same on all four sides. Now you see me doing that template. I put some tape over it and transferred all my lines, including the front spacers, so that I know where to go. And then now I'm just finding the right radius that I want. And I actually ended up deciding not to go ahead and do that and freehand it because it was just too curvy and I wanted it to be more of a flow rather than a straight curve. This is something that was really helpful, is after putting that tape on, I took a number 2 pencil and then just etched along the side of that guard profile. This let me know how much room I have to work with. So I'm not just freehand drawing. Well, I'm freehand drawing, but I'm not going over where I have that room. So I'm just going to draw this on this side, and then you'll see me transfer that and how I transfer that onto the rest of the sides. The last thing that I do before peeling the tape off to make the final template is cut out the tang slot, and this is just going to help with the rest of the lineup once I put it back on there. So now I'm going to peel that tape off and put it on a piece of paper, and that paper is just going to provide a nice backer for the tape, and it'll enable me to flip it around when I go to the other sides to make something that is symmetrical. So now that I have it on there, I'm just going to cut out the profile of that guard and make a little template to transfer back onto the guard. I cut some little notches on the center line of my template, and this is so that when I put it back on the guard, I can match it up with the center line of my guard to make sure that everything is going to be straight and square. That was my mouth, I promise. Now, this is the real value of having that paper backer, so that I can flip the template around, realign it up with the other side, and then those other two sides are going to be symmetrical as well. So the way that you do this, you just have to do one side and then make sure that your lineup is done really well, or your layout for the lineup is done really well. And then that way you can put that one section on all four sides, and all four sides are going to equally match each other. Another way that you can do this, though, is you could do an entire half and then flip it over and do the other half. Or if you're doing a guard shape that you want to be asymmetrical, then you could do, a couple different templates or different stuff like that. But whatever you're going for, you can make custom templates to that shape and then flip it around however you want. And you can see too on all this stuff, I'm using magnets to stick it on there, which is really great. It just helps to keep it in place. Now, if you're working on metal that is non-magnetic or handle material or something like that, then you might have to tape it down. But if you're working on any type of steel or iron, have a couple little magnets handy, and it makes this process go a lot easier, and you don't have to worry about the template moving around at all. Now that I have my layout all symmetrical and clean, it's time to go back to the grinder. I start on the flat platen and get everything rough shaped down pretty close to the line, but I want to keep a little bit of wiggle room to make sure that I can get everything clean and perfectly symmetrical. So once all that's ground, I put on my integral waterfall platen, and I believe I had a 2-inch radius on here, and I'm cleaning all that up and making it flat. Once it's all flat, I'm going to go do another fit up and really check everything to make sure that it is in line with the blade and with the rest of the handle. Time to get back to work on the shield part of the guard. So here I am cleaning up the bottom of the shield into that transition point and making it really crisp with a file. Now I want to go back to the light table and make a template for the guard. I've already profiled the thickness of the guard, but I want to profile the shape. So I'm going to trace over the guard on my 1-to-1 template, and I'm just tracing over half of it because I'm going to do the same process that I did before and transfer it onto the quillins on the guard onto all 4 sides, or I guess in this case it's actually just 2 sides going back and forth. But I want to make sure that both those sides are perfectly symmetrical, so that's why I only traced one side of the template, because even though on the template they're both symmetrical, sometimes in the tracing process there's going to be some imperfections, and if there are going to be imperfections, you want those imperfections to be symmetrical on both sides. I realize that I'm going to have to bend the guard up a little bit, so actually what I'm marking out right here is just the lines to cut on the bandsaw so that I can bend that up a little bit, and then I'll come back and retrace that over. So I marked that out. Now I'm going over to the bandsaw to mark where I want the split to be, and that'll just give me some room to do a little bit of moving on the guard to give myself a little bit of extra space. Here we break out the torch, heat it up, and it doesn't need much bending, but just a little bit to make sure that I have enough room. Pliers may not have been the best way to do this. I thought it was going to be a little bit easier to bend than it was. I think probably if I were to do this again next time, I might get a cold chisel and hammer it in there, and that would probably be a lot easier, at least to get the initial bend, and then pliers might be a little bit easier from there. Now that I got my bends in there and gave myself a little bit of extra room, it's time to go back and trace my template onto the guard. I'm using a carbide scribe here to make sure that I have a permanent mark. I didn't have to go over it with Dicom because I had a little bit of the scale on there from the torching process, so it actually worked as a nice background. Now I go back over to the grinder. I used a slack belt because of how thin that gap was. I really needed a way to be able to grind it, and the only way to do that, the thinnest possible way to grind it is just with the belt. So I'm just trying to take it slow, at least, well, once I get closer. For now, I'm just trying to hog off all that material. And then once all of that is hogged off and cleaned up and I got the insides, then I'm going to go over to my small wheel attachment and clean up the rounding on the outside of it. After all of that is done, I wanted to do some little flares on the, so it looks like it's splitting like a floral element, as a floral element should. So I marked off, I'm going up to my Sharpie line right there and just filing and trying to feather that crack. Now I'm chamfering the shield element on the part that meets the tang so that it creates a smooth transition. I started on the belt, and then I'm going to go and clean all of that up with files. I scribed some lines on there to make sure that it's all even. The next part is to grind the crest on the shield. This is actually very similar to grinding the bevels on the Dagger. So I'm scribing the center point on each side, and then I'm going to mark that out with my ruler. And then I'm going to go back over to the grinder and rough grind those in. I also scribed the thickness that I'm going for on the shield. It's important when doing anything that you make sure that you're getting that thickness down so that it is even and clean all the way across. After I have that cleaned up on the grinder, then I went back over to the file and just took those lines again to make sure that there was a cool transition and that the shield was really distinct. And then it's time to hand sand and get that all cleaned up and ready to start the engraving process on the shield. Once the shield is done, I'm now going to work on shaping the center spacer. So just going in, I had to custom make some files here, sort of make like a knife blade file to get in and get the angle that I want. And then I'm just going slowly rotating it and rounding it as I go across to make that center element look like a ball. After I got the centerpiece profiled, then I went to clean it up with the little tapered disc of, this is Eviflex, but it's very similar to Kratex if you have that. They're little silicone polishing discs and wheels. And so I'm just cleaning cleaning all that up, getting in there, cleaning up the transitions and making it all smoothed out. Once I have that all smoothed out, then it's time to hand sand that center element to make sure it's all even. Now that I have the center element done, it's time to start doing the layout on the pommel. This one was pretty tricky. The whole pommel was carved. So I'm starting by drawing the scroll on one side and making it how I want it. And then I'm going to take my calipers and measure on that side and transition it over onto the other side. Once all of the measurements have been transitioned over, then I can go ahead and start scribing the other side as well. Here I'm going and I'm just looking at both sides, trying to mirror it. Having those measurements really helps for reference points so that I'm not making this side too large or too small. Once the layout is on there, it's time to actually start sculpting. The first thing I do is hog off the big sections of material that I can with the grinder without going too far. Once the big sections are hogged off, then I'm going to start getting in with my carbide Dremel bit and getting into the smaller and more detailed portions. So I'm actually going to end up having to redo the scribing process. You can see right here that I'm just trying to clean up all around and get that outline done. But then once that outline's done, I'm going to have to go back over and go up to those center lines because I want to have the pommel rounded out as well. So then once that pommel was rounded out, I went back over, rescribed it, did all my measurements again with my scribe, and then it's back to carving. So all of this carving I did with the Dremel, and then I cleaned it up with those polishing wheels as well. Before that final cleanup process, went in with some files to make sure that all of the lines are flat on the parts that need to be. And then you really have a lot of control too, so making sure that those rounded portions of the scrolls are perfect and exactly how I want them. You have a lot more control with a file than you do with the Dremel tool. Some parts I couldn't get to with my file, so I actually decided to rip down a 320 grit belt to like 1/4 of an inch, and then I used that on the slack portion, kind of how I shaped the guard, but now I'm using it on the pommel to get into those really, really thin elements. And then I put on a full belt and am just rounding out on the slack the outside to make sure that all of those scrolls are really nice and clean. You don't want any sharp points on scrolls. You don't want any bulges or anything like that. Now I'm going back in with those EviFlex wheels and discs and cleaning up and polishing the whole pommel. The nice thing about these EviFlex bits is they're really easy to shape. So this one I actually shaped on some 220 grit sandpaper, just tapered it down so it was a little bit thicker at the base, and then down to like a 1/8 inch. That way I could get into those really tiny areas of the scroll. Now that the pommel's done, it's time to start engraving the center element. Here I'm carving out the channels for the gold overlay. At this point, I decided to put the gold balls on the pommel. So here I am heating them up to a really hot temperature with the oxyacetylene, and then putting some gold in there and sticking it into the pommel. After I got all three of those gold balls in there, I went over to the wire wheel and cleaned up all the scale that developed from the oxyacetylene. Continuing with the embellishments, I'm now carving the channels on the shield portion of the guard. So you can already see on the one side, I have all those channels cut and the little barbs raised up. Typically when I do straight channels, I only undercut if I have to, because sometimes with the undercutting process, you can actually create a different size channel than you were originally intending. So anyways, right here, I am just cutting out the scrolls. And then once I get all of the scroll lines done, the skeleton, then I'll go back into all of the floral elements and carve all of those out. Now you can see me putting in those little barbs. So I'm just going in at pretty steep angle and creating little barbs in that channel going both directions. So that gives the gold something to hold to when you smash it in. And quench. Little fireball. All the fittings need to be heat treated because they are Damascus, and we really want to bring out the contrast in that pattern, which the heat treating will do. On to smashing gold. This video is sped up so that you guys can see the whole process, but here I just wanted to show going around a corner. You kind of have to push it back the other way to get it to bend how you want, and then you can go along and go through all the little lines that you carved out. Here we are smashing it in. Just go over with a little bit and get it all in there so it holds nice and tight. Once it's all in there, then you got to sand it down. So I usually start with a file, get it pretty close, and then just go through grits of sandpaper with a hard backer and a very thin amount of sandpaper on there to keep it as flat as possible and sand it all down to flush. That's for inlay. You'll see when I do the overlay, you don't want to do this process. Or if you do, you just want to do it lightly on the top so the whole surface is even, and then you go ahead and sculpt it. So here I'm smashing in the overlay. With overlay, I think I said this before, but with overlay, the material, gold, copper, whatever, is actually on top of the metal rather than you can see the inlay is flush or in the metal. So that's the difference between inlay and overlay. And with overlay, you really want to keep that extra amount of material on top to make sure that you have enough to carve, which you can see me doing right here. So for the overlay or any carving, sculpting carving, I use a whole bunch of different chisels. Right here, I'm using a 90-degree V chisel and just trying to highlight some of those, the skeleton lines and bring those leaves together. So you go back and forth from carving with a chisel to sculpting with little punches. You can make different size punches for what you want, whatever texture that you want. Also different materials, so you can use a carbide or a steel punch. It'll give you a little bit of a hammered look, and then you can smooth it all out with a brass or bronze punch. That'll make it more smooth and polished, and then you can even, I don't think I took a video of it, but you can use little ceramic sanding stones, and that will really even everything out on all of your lines and get it up to like a 3000 grit. Then once I do that, I will go over it with some 4-0 steel wool, whatever the highest grade of steel wool is, and that will really polish it. And then hit it with a sunshine cloth, which is a polishing cloth, and that'll give it that really bright mirror finish. It'll make it pop. Once I got that ornamentation done, then it's time to do the fluting on the handle. So this handle is elk antler. I already did my layout on the flutes and started the main channels, and now I'm going in and rounding out each of those channels and preparing it for the twisted wire inlay. I also want to make sure that my handle will line up with my fittings, so I traced out the fittings and then I'm now filing the chamfer on the ends of the handle to match up to those fittings. I'm now coating the antler in potassium permanganate, and it goes on purple and dries brown. It's actually soaks into the antler and oxidizes, so it's a very durable stain, and it's a great base coat for other stains on top of it. Once the antler is drying, then I'm going to get my twisted gold wire all ready. So I made a little jig in my drill, got the wire fully annealed where I need it, and then now I am spinning it to twist it. And once it's all twisted and even, you can see how brown that potassium permanganate turns the antler. But now that my wire is all twisted and ready to go, it's time to inlay it. So going for a physical hold, I still put in some super glue just to be safe, but you shouldn't need super glue when you do this. I just do it for an extra precaution. So I got my holes in there to hold it all tight, and I'm getting that wire as tight as I possibly can, pushing it in with pliers, pulling it really tight, and it's a really firm fit in that handle. All right, it's time to finally glue the whole thing together. I got the fittings etched and finished. I got the handle all stained how I want it, stained and dyed and finished. Now I am epoxying it on there, and then I will put in the final pin to hold it all together. Here I'm just cleaning up some excess epoxy from the fitting process with some WD-40 and a Q-tip. Now we get to look at the finished piece. This is definitely my best work so far. The Ampelos dagger was inspired by the icon of the living vine. The 5 golden balls are symbolic of the 5 wounds of Christ. There's 12 leaves on there that represent the 12 apostles. Those leaf shapes are also inspired by the icon. I encourage you to go look at it. Also the twisted Damascus, everything about it, it all comes from that. But my favorite part is definitely the gold overlay. I really like how it turned out. And it's a really nice accent to the overall piece. So I'm excited to incorporate things that I learned from this in the future, and fix some things that I didn't do quite as well as I would have liked. One thing I do think I need to get better at from this build is some of my Damascus finishing. I really like how it turned out, but I want to work in the future on making those brights even brighter as I continue to grow as a bladesmith. So thank you so much for following along this build and checking it out, and I hope you all enjoyed it as much as I enjoyed making it.